All right, let's just jump right in. Think about this. Every single minute, we're streaming over 400,000 hours of video and placing millions of online orders. I mean, that's not just a flood of data, right? It's a full-on, constant, chaotic digital storm. And hidden somewhere in all that chaos is some incredible value just waiting to be found. And we're way past talking about gigabytes or even terabytes anymore. The scale we're operating on today is measured in petabytes. To even try and wrap your head around that, a single petabyte could store the DNA of every single person in the United States twice. It's a scale that's so massive, it requires a totally new way of thinking about engineering. So the big question is, who are the people that actually build the systems to tame this beast? Who takes all this raw, messy, untamed data and turns it into something structured, reliable, and actually useful? Well, that's where the modern data engineer comes in. Honestly, this is the perfect way to frame it. You've probably heard that data is the new oil. Well, if that's true, then data engineers are the ones building the refineries, the pipelines, the entire infrastructure. They really are the civil engineers of our digital world, and our whole information economy is built on the foundations they create. So what do? At their core, their job is to design, build, and manage these huge data highways. These highways let information flow from all kinds of different sources to the people who need it, like analysts and data scientists. Without the data engineer, all that valuable raw data, it's really just digital noise. Now, just like any kind of engineering, data engineering has its own set of proven blueprints. And when they're talking about building these data pipelines, the two big ones you're going to hear about are ETL and ELT. Getting the difference between these two is absolutely key to understanding the whole modern data landscape. So first, we've got the classic approach, ETL. It stands for Extract, Transform, Load. The process is right there in the name. You pull the data out, that's the extract. Then you clean it up and reshape it on a separate server, that's the transform. And only after it's all neat and tidy do you load it into its final home, usually a data warehouse. It's a very methodical process that's been the industry standard for a long, long time. But now there's a new kid on the block, ELT, which is Extract, Load, Transform. Did you catch that? The T and the L are flipped. With ELT, you extract the raw data and you immediately load it, mess and all, into a super powerful, modern system like a data warehouse. All the hard work, the transformation, happens inside that powerful system, taking advantage of its massive processing power. And this table really lays it all out. With old school ETL, all the processing is done on separate servers, which means you have to decide on all your transformations ahead of time, and you're paying for that infrastructure whether you're using it or not. But with modern ELT, everything happens in one place. This gives you this incredible flexibility to change things on the fly as business needs change. Plus, your costs are often consumption-based, meaning you only pay for what you actually use. It's a game changer. Okay, so if those are the blueprints, what are the actual tools? What kind of technologies are these engineers using to build these massive data highways? Let's take a look at the toolkit. Well, first things first, pretty much everything these days is happening in the cloud. The market is completely dominated by the big three: Amazon Web Services, or AWS, Microsoft Azure, and Google Cloud Platform, GCP. This is the new frontier where all this modern data infrastructure gets built. It gives you a kind of scale and power that was basically science fiction just 10 years ago. And, while there are three main players, the choice often really comes down to what kind of environment you're in. AWS is the undisputed market leader, with a gigantic ecosystem of services for pretty much anything you can imagine. Azure, on the other hand, is the natural choice for any company that's already heavily invested in the Microsoft universe, because it just integrates so smoothly with tools like Office 365. But it's not just about picking a cloud. Data engineers need a whole arsenal of technical skills. We're talking big data tech like Apache Spark to process data on a massive scale, the ability to design data warehouses, and of course, deep knowledge of databases. And more, they're also getting their hands dirty with machine learning frameworks and even data viz tools to help make that data understandable to everyone else. And this right here, this is the foundation of everything. No matter how complicated the pipeline gets, at the end of the day, most of the data is sitting in simple, structured tables, just like this. And the one language that lets a data engineer talk to these tables, ask them questions, and tell them what to do is SQL. It's the one skill that is absolutely 100% non-negotiable. But look, being a technical wizard is only half the battle. The truly great data engineers have another set of skills that are just as important, but you can't really list them on a resume. We're talking about the human element. This quote from an engineer on Reddit just hits the nail on the head. You can build the most elegant, most powerful data pipeline in the world, but if you can't explain why it matters to someone in marketing or sales, its impact is going to be seriously limited. And it really just boils down to these three things. First, communication. Being able to explain really complex stuff in a simple way, and crucially, without making the other person feel dumb. Second, collaboration. Just being an easygoing person that people actually want to have on their team. And maybe the most important of all, listening. Truly understanding what the business actually needs before you even think about writing a line of code. So, how do you prove you've got these skills in a job interview? The STAR method is a fantastic way to do it. It's a simple framework for telling a great story. You set the situation, explain the task you were given, detail the actions you took, and then, most importantly, you share the result. It transforms your experience from just a boring list of responsibilities into a powerful story of your impact. Okay, let's bring it all home. We've looked at the blueprints, the technical tools, and the human skills. So, what does it all add up to? What is it that really makes a great data engineer in today's world? Well, for one, they see where the puck is going. I mean, just look at this chart. The adoption of that new ELT model has more than tripled just since 2020. This is a massive shift, and it's happening because we need more flexible and powerful ways to deal with all this raw data we're collecting. A great data engineer doesn't fight this change, they embrace it. So when you boil it all down, a great data engineer isn't just a coder. They're not just a database admin. They're a hybrid. They're a technical master who is also an amazing communicator. They build systems that are not only powerful and reliable, but are also perfectly designed to solve the actual problems the organization is facing. Because here's the thing, the specific tools we're talking about today, the cloud platforms, the programming languages, they're going to change. They always do. The tools are temporary. So the real question is about your mindset. Are you building the foundational principles that will let you adapt? A great engineer is a lifelong learner, always focused on the why, not just the what. Because that's how you'll keep turning chaos into clarity, no matter what new tools the future throws at you.